All right, so in this video, we're going to go through sample question 9 from the Society of Actuaries ExamP list of sample questions, right? Exciting stuff, yeah? So the question reads, an insurance company examines its pool of auto insurance customers and gathers the following, right? And then gives us a list of 4 pieces of information. 1, all customers insure at least one car, right? Which makes sense if you have auto insurance. 2, 70% of customers insure more than one car. 3, 20% of customers insure a sports car. And then 4, of the customers who insure more than one car, 15% insure specifically a sports car. Right? So calculate the probability that a randomly selected customer insures exactly one car and that car is not a sports car. Okay, now if you haven't already, I suggest trying the question yourself before going to this video, right? Just give it a shot, see how you do. So let's look at where to begin. Now, it gives us this list of information, and immediately I want to draw something like a nice puppy. No, but the way it gives us the information, right? Everyone owns a car, everybody that has this type of insurance, auto insurance. And either you own more than one car or you don't, right? So those are mutually exclusive sets. So rather than drawing a Venn diagram, I'm going to make this more like a chart, right? And the categories it gives me is number of cars as well as whether or not you own a sports car. So I'm going to say, where let's say X is the number of cars. Let's say you own exactly one car. Right, that'll be this row, and you own more than one car. Those are the 2 options, and you can't be in both. That's why there's no overlap. And this one will be either you insure a sports car, S, or you don't insure a sports car, S complement. It states 70% of customers insure more than one car. So this is going to be 0.7 here, right? That's what this row should add up to. And, you know, this would imply that this row should be 0.3 because everyone owns a car and it's either you own exactly one or more than one. And the total probability should add up to 1. Similarly, 20% of customers insure a sports car. It's 0.2. That would imply that 80% do not insure a sports car. Now, the 4th piece of information is not too tricky, right? It's still a pretty straightforward problem, but it can be the one that leads to some misinterpretation. Of the customers who insure more than one car, 15% insure a sports car, right? Of these guys, 15% insure a sports car. Some people might assume that 0.15 would go in this box, but that's not true. What goes in this box is the intersection, right, of people that own a sports car and own more than one car, right? That's what goes here. What it gives us is of the customers who insure more than one car, 15% own a sports car. That is saying the probability of somebody owning a sports car given, right? We already know that this is the group of customers that own more than one car, is equal to 0.15, which is not what goes in here. Okay, so we do want to figure out what goes in here, and we can do that based off conditional probability. We know that this is the same thing as saying the probability that somebody owns a sports car and insures more than one car, which is, you know, what that empty box is, divided by the probability that they insure more than one car, right? These 2 are equivalent. You should have that formula down by heart. And that's still equal to 0.15. And given that we know the fact that the probability of insuring more than one car is 0.7, this should be 0.7 times 0.15. Right, so I'm going to cross this out right at 0.7 here just because I'm running out of room. And then I multiply it to both sides. and 0.7 times 0.15 is 0.105. So the probability that somebody owns a sports car and insures more than one car, that is 0.105. Now we can start figuring out the rest of the box. And you know what? I'm gonna do that, right? We don't necessarily need it for what they're exactly asking us. However, just for the purposes of explaining this, how to use a chart like this, right? We can figure that out. So I know this all should add up to 0.7. So I just do 0.7 minus 0.105, and I get 0.595. This entire column should add up to 0.8. So 0.8 minus 0.595 gets us 0.205. And this column here, or sorry, this row should add up to 0.3. So 0.3 minus 0.205 should be 0.095. Now, what is it asking us? The question is ultimately asking us the probability that a randomly selected customer insures exactly one car, and that car is not a sports car. Okay, so we're looking for this, the probability that you insure exactly one car and it's not a sports car. Well, that is this intersection right here. That's this box, right? And I can't stress that enough. The thing in this box is the intersection, not a conditional probability. 0.205. And I harp on that because that is a mistake I made when I first started looking at these and trying this box method, right? I love this chart thing because it makes this question so much easier as long as you just kind of remember that one little thing. Okay, and so this is what the question's asking us to find. Now the answer choices are to two decimal places, so rounding this, right, gets us 0.21, which is answer choice B. Okay, hopefully I made that problem a little bit easier for anybody finding it a bit tricky. General takeaways from this, what can we learn from this in general, right? Because you're not going to get this exact problem again. You're going to get stuff like this. When we're given information, try to draw a diagram to make things make more sense. When things are mutually exclusive, right, you can, and there is no overlap, you can kind of make a chart like this where the rows add up to the total probabilities, right? So, for example, here you have people that own exactly one car. Either they insure a sports car or they don't. We know 30% own exactly one car. So that means of the people that either insure a sports car or don't insure a sports car, that should add up to 30% or 0.3. Another thing to remember, formula for conditional probability. Probability of A given B is equal to the probability of A and B divided by the probability of B, right? And this is not just so you can figure out conditional probability. Sometimes you're given conditional probability and you need to find one of the other things, right? Very, very basic concept in algebra. If you have this thing where it's like, three unknowns and you're given two of them, you can find the third thing, right? There are plenty of problems where you're given these two things and you need to figure out what this is. But that's the basics of this problem. Hopefully, like I said, hopefully if that was confusing you, I cleared it up. If there are any questions, throw something down in the comments. I'll answer to the best of my abilities. If you want to see some more questions, I have a playlist. And if this video helped you out, hit the like button because that definitely helps me out. Other than that, good luck, guys.